The event structure allows you to define the behavior of the application when you change the value of a control, press a keyboard or mouse button, move a mouse, or even when you resize the window. The structure has this colorful frame. It's similar to a case structure, as it uses subdiagrams for defining different events. The structure has an event selector, a timeout terminal, and event parameters. When you press a key, it shows you which one. And when you move the mouse, its coordinates will be displayed. To define an event, use the context menu. Here, you can edit current, add new or duplicate event, which you will find very useful. Here you see the name of a current event frame that you're editing. You can choose a different frame. You can also add or remove events from the edited frame. A good habit is to have only one event per frame. The most popular events come from the Controls menu, which displays a list of all the items placed on the front panel. Depending on the source, here you will see different events. The most common are Control Value Change, Control Mouse Down, Panel Mouse Move, VI Panel Close, or Application Timeout, which is a default one for the structure. In addition to the events marked with a green arrow, you can also select so-called filtered events, marked with a red arrow and a question mark. When those two events are defined, the red one will execute first. And inside that red event, you may decide to discard the second one. For example, when you right-click on a graph, a context menu appears by default. You can remove this right-click event like this. Check which button was pressed. And if it equals 2, then discard the event. It will result in completely ignoring the right mouse button. Events provide a reference to the source so that you can use properties or invoke nodes to interact with that element. Like here, when you right-click on the graph, you can read the mouse position and see if it's close to the X scale. If it is within the close range of the scale and it's a right mouse click, discard the event but still do the auto scale. So now when you press on the plot, you see the context menu. When you press the scale, no menu is displayed and auto scale is performed. The event structure should be used with a while loop as a user interface event handler, or in a state machine architecture, in the waiting for event state. A few tips to keep in mind. Place event-related controls inside the proper frame, especially Boolean buttons. The mouse down event is triggered when the cursor is over a control. But the associated mouse up event should be defined more broadly, since the cursor can move outside the control area. To accommodate this, consider using the pane mouse up. Events are queued and executed one after another. Therefore, it's important that the event structure works as quickly as possible to make the application responsive. You may need to move time-consuming operations to other places. To do this, you may need to use one of the multi-loop architectures or register a callback event, which we will cover in another video. Using the event structure in this manner is called a statically defined approach, and it begins capturing events as soon as the program starts. So, if any event happens during the initializing, it will be queued and executed immediately after data flow reaches event structure. This behavior can be changed by dynamic event registration, which we cover in another video. Overall, the event structure allows you to significantly improve the user experience and interaction with the program.